Hi, everyone. Welcome to today's live. I think we had a really nice session together on Tuesday talking about, I'm going to share my screen, and I'm pretty sure I figured out how to do it. I had trouble the last time. Let's see. Oh, I think I got it this time. I think I got it. Okay. So we started talking about how to succeed at reliability-centered maintenance. And okay, yes, so I totally have my screen sharing, I think. Okay, hold on, I'm just making sure. I'm pretty sure I have it. So while I'm waiting for that, this is what I want to tell you, or what I want to go through. So as you know, I'm still kind of new to LinkedIn Live. And when you're new to something, you know, it takes a while to get the bugs out, right? And one thing that I wanted to share with you is this, because we talked about a failure pattern the other day where we said that this is, I'm going to stop sharing for a second. Let's see. Hold on, I'm almost there. Okay, where we talked about that this x-axis is age and the y-axis is the conditional probability of failure, right? Now, we have this one failure mode where you can see when things are new, the conditional probability of failure is higher. So that's what happened to me on Tuesday when I didn't know how to share my screen, where there was just one button that I wasn't clicking properly in StreamYard. But I got that going on now, and so I got that fixed. But see, this happens with our equipment too, like when our equipment is new and we're not sure how to use it, or you know, this is also stuff like a tool is left behind or someone does something incorrectly. All that infant mortality when something is new and you're working out the bugs, well, it happens with people too. And that's what happened to me the other day. But I got it going on now. So now what I'm going to do is I'm going to share my screen and we're going to get into the guts of today. And I'm really excited about it because it's something really important. And actually, the details of what I have ready for today, I've not shared before. So this is going to be something new. Okay, so let's see. All right, I think I got it. Yes. Okay. So on Tuesday, just to quickly recap, on day one, we talked about understanding what reliability-centered maintenance is and what it can do, right? And we talked about the three knots, that reliability-centered maintenance is not a maintenance strategy, it's not software, and it's not the only solution to achieve reliability goals, right? So just, I want to make sure everyone is clear on that, right? So it's not a maintenance strategy, it's not software, and it's not the only solution to achieve reliability goals. And I'm going to change this window because you can't see me, and that just feels very impersonal to me. Okay, let's do this again now. Okay, I got it. So we talked about it not being a maintenance strategy, and we talked about what reliability-centered maintenance is. So it's a process that you use to identify what proactive maintenance tasks you should be doing and some other default strategies, right? So it's 7 steps, and we've got functions, functional failures, failure modes, and failure effects. Now, when I use the term failure mode, I'm talking about a failure cause. It's what specifically causes functional failure. So I'm using the term failure cause and failure mode synonymously. Now, when we do steps 1 through 4, that makes up the FMEA, or the failure modes and effects analysis. So when you do reliability-centered maintenance, the need to do an FMEA is largely satisfied. Now, when we throw step 5 into the mix with failure consequences, we get a FMECA, or a failure modes, effects, and criticality analysis. And then we move on to step 6, is when we identify if there's any proactive maintenance we should be doing. And remember, we talked about when you do RCM, you identify optimized maintenance tasks. And then step 7, where there are also some other default strategies that we could come up with, like failure finding our protective devices, like our fire suppression systems, etc. So, and remember that step 6 includes condition-based maintenance. So a lot of times people will say, should I do RCM or CBM? Well, CBM, the consideration of condition-based maintenance, is part of the process. So now that we've done that quick review, I want to talk about how to apply reliability-centered maintenance successfully. Now, to do so, of course, there's more than just this topic, but today I want to focus on scope of analysis, because the scope of our analysis is really important to RCM success. If it's too narrow or too large, it can lead to a lot of problems, right? Okay, I'm just going to look at the comments. Hi, Subramanyam. Keaton, hello, good to see you again. Good to see you too. Keaton says, while making FMEA on any equipment, what is more important? This should be teamwork or individual work. In my opinion, Keaton, it should be teamwork, because in almost all cases, there isn't just one person who knows everything about a piece of equipment. So I advocate a facilitated working group approach. Okay, so now let's get into the scope. Here's the crux of my message. The goal of your RCM analysis drives your scope. Now, you can have more than one goal. You could have a goal to create a proactive maintenance plan. Maybe your goal is you don't understand your equipment and you really want to figure out exactly how it works. That could be a goal of an RCM analysis. It could be that and proactive maintenance, right? Maybe your equipment is suffering from chronic failure and you want to figure out once and for all what's causing that chronic failure. Well, that could be a goal too. All of these different goals drive the scope, but it drives the scope in 2 ways. What you do RCM analysis on, and then once you decide what you're going to do RCM analysis on, what matters is how deeply or how detailed you get with your failure causes with respect to that particular piece of equipment. So let's look at the first part, and let's look at scope of analysis from an asset level, right? Figuring out what are we going to do reliability-centered maintenance on, okay? So let's just say we are in a manufacturing plant, and let's say we're going to talk about the plant air system, right? Well, that's a really big system. So to say I'm going to do an RCM analysis on plant air, can you do it on the plant air system? Yes. But in my opinion, you need to like chunk it up or chunk it out, right? You can't do it all. You can't do one analysis on plant air because it will feel and be so big that it will just be way too cumbersome. And it's almost like it would take so long to see light at the end of the tunnel, right? So we can break plant air down. We can break plant air down into, say, the compressor, the air compressor, the air dryer system, and the tower water distribution system. Now we can further break that down into the PLC, or the programmable logic controller, meaning if we can break down the compressor into the programmable logic controller, the inlet air filters, the main motor, the lubrication system, the intercoolers, and so on. So you see what we're doing here. We're breaking each part down. We broke the plant air down into these 3 separate systems. And now we're breaking down the compressor system into all these different systems. Now, of course, there are more than these 5 that I have listed. But we can even go deeper, and we can break down this lubrication system. And I'm gonna stop sharing my camera so that this is bigger for you to see. Let me do that. Okay, yep. Let's do this again. All right, I'm gonna be a whiz at this by the time I'm done. I think my thing is I need another screen, and then it would be better for you guys. But anyway, that's okay. We're gonna do it from here. Okay. Okay, so now we can take the lubrication system and we can break that down. We can break that down into the prelude pump and the main oil pump and oil filters and oil filter differential pressure gauges and oil heaters and so on, right? So how detailed you go is dependent upon your goals. Now, could you do an Rcm analysis on the air compressor? Absolutely. And in my opinion, that would be a good scope. It would take maybe like depending upon how big the compressor is, roughly 2 weeks with a facilitated working group approach. But let's just say you just want to do it on the lubrication system. Well, you can do that too. It just depends on what your goal is. So if your goal is proactive maintenance for the compressor system, then yes, absolutely, you could do it at the compressor level. But at the plant air level, that would be just like way too much. That would be really overwhelming. Okay, I'm going to stop and look at the comments real quickly. Ali says FMEA is brainstorming methodology. Yes, it is, to a very large degree. Okay. Ali says first step is to draw a taxonomy, asset technical hierarchy. Yes, exactly. I totally agree. And that's essentially what I have done here, right? So now let's go a little bit deeper. And let's say, now I want to show you scope of analysis if we're talking about what our goal is, right? So let's just take out our main motor for our compressor. And let's say we want to assign a proactive maintenance program for just the motor, all right? So the goal is a proactive maintenance plan. Well, now, if you'll recall, what I said is that failure modes, or I'm using the term synonymous, failure causes, specific causes of failure are so incredibly important. It's one of the most important steps in an Rcm analysis because we manage physical assets at the failure mode level. So I want to go through, if we were going to analyze this electric motor, here is an example of the failure modes that we would include in our analysis if the goal was proactive maintenance. Bearings wear due to normal use. Bearing oil deteriorates due to normal use. Intake or discharge screen clogs due to normal use. And fails internally. Now, I want to pause for a second and talk about these things. And I want to show my camera again because I have an analogy to make for you. Okay, something that my mentor, John Mowbray, used to say, and my friend and colleague, Chris James, reminded me that John Mowbray used to say this. John Mowbray used to say that the currency of our equipment is just like, as human beings, our currency is money, right? So here we've got American dollars, right? And we talked about this on day one, where not all failure modes are created equal, right? And sometimes what happens when an Rcm analysis is not done properly is that failure modes are written at way too deep a level, and you end up with all of this when really all you needed was this. Now, let me show you what I mean. So we've already said bearings wear due to normal use. The key when you write your failure modes in an FMEA is they have to be written at a level at which you can assign an appropriate failure management strategy. So let's look at bearings wear due to normal use. What is this task what is this failure mode going to lead us to do? If we use our common sense, right? And our failure causes bearings wear due to normal use, what might we do? Put that in the chat. And in the meantime, I'm going to take a look at the chat. Ashish says predictive maintenance will play a key role in case of compressors. Yes, predictive maintenance is very important. Luis, thank you so much. Luis, thank you so much. I really appreciate you. I hope you know that. Okay. Hi, Vladimir. Hi, Fabio. Yes, I'm gonna post all of these lives on my website. So if you see, do you see right here in this header where it says rcmtrainingonline.com/subscribe? If you are already subscribed to my email list, I'm going to send out an email and let you know when all of these lives are posted. So you'll have the information. So do subscribe if you're not already. And then you'll also I send out emails to notify when I'm going to go live and when I've got other things going on. And I publish weekly videos. So do subscribe if you're not already. Okay, Subramanyam says where? Kotesh says reliability analysis with example. I'm not sure what that means. Kotesh, you want to see the decision tree. I'll show you that at the end of this day. Okay, so let's go back for bearing wears due to normal use. When I put that through the Rcm decision logic, I am going to be thinking ahead. How can I manage that? So when we get through the Rcm process, right, I'm going to go through the decision diagram, which I'll show you because someone just asked. I'll show you that in a minute. But if we just use our common sense, the something that I would consider is vibration analysis, right? So that failure mode is written at an appropriate level that I can arrive at a failure management strategy, that being vibration analysis. The same thing with bearing oil deteriorates due to normal use. What's that going to lead me to do? Maybe a scheduled replacement of the oil every year maybe, or maybe I might decide to do condition-based maintenance and do oil analysis. Let's look at this one. Intake or discharge screen clogs due to normal use. Well, now when I go through my Rcm logic, I'm going to be able to consider, do I have some gauges? Do I have a way of detecting the differential pressure across the screen? Could I do condition-based maintenance and replace it only when it needs it? Or do I need to do a scheduled replacement task on that? So you see how those first three failure modes are written at a level that it's common sense. I can do something about it. Now look at the last one that I have. Fails internally due to electrical failure. Now, if we wanted to, I want you to put a number in the chat. If we wanted to, we could go into painful detail into the guts of this electric motor, couldn't we? All of the various electrical components that's inside the guts of the motor. I mean, depending upon how detailed we go, we could get 10, 15, 20, 30 or more failure modes, right? But what is the point in that? If my goal is to identify proactive maintenance, then there's no reason to go that deep inside the motor. Now, if I'm doing a design analysis, right? Let's say the goal is to confirm that the design of my electric motor is appropriate. Well, then I wouldn't say fails internally. I would have to write failure modes for those internal components. But when the goal is proactive maintenance, I don't need to do that. So see, that's the equivalent of this. For electrical failure of the motor, instead of listing all of this, all I need to do is list this, right? Or this, right? Because each failure mode has different consequences, right? But the point is that a lot of times, to bring it back to the reason why we're here and talking about how to succeed at Rcm, one of the reasons why Rcm fails is because it's not done properly. And one major reason is that failure modes are written at way too detailed a level or too high a level. Like, I can't just say electric motor fails and moves on, because what about my bearings? What about my oil? What about my intake or discharge screen, right? There may be some proactive tasks I have to do there. That's the key to getting our failure modes written at the right level. Now, for each component that you come across in an Rcm analysis, it's not going to be all at the same level. But now, see, this brings us back to another topic, and that is, if you're going to do Rcm, you need to make sure, if you're going to do it, that you're properly trained and you understand the process, or you work with someone who knows the process. Because, I mean, I know there are a lot of people out there, and maybe sometimes it might sound like a sales pitch to you. But just speaking generically, I've seen a lot of organizations waste a lot of time and a lot of money on Rcm analyses because they weren't executed properly, right? And again, a big reason is that failure modes are written at way too deep a level. Now, if we were going to do Rcm, now let me just make one more point. Another point is this. Yes, we could do Rcm on the plant air system, right? With the compressor, the air dryer system, tower water distribution system. But then what we need to do is break all these components down. And if you know reliability-centered maintenance and you are experienced in it, you can look at a tech manual and figure out how many failure modes you're probably going to come up with. And so you can estimate how long it's going to take. So you can work backwards. If you know you want to do, you have this week to do Rcm, well, then you figure out what your scope will be, right? And then, so let's say our scope of analysis is the compressor. Well, we're probably going to just say PLC fails, right? If our goal is proactive maintenance, we're not going to get into the guts of the PLC, the programmable logic controller. Can you imagine that analysis? Now, should you do an Rcm analysis on that? You may need to. But the goal, it wouldn't be because the goal is proactive maintenance. So you see how there are all of these different things. Number one, do your hierarchy, right? What do you think you need to do Rcm on? If you're having trouble with the compressor, focus in on that. And then identify what your goal is, because your goal will drive the level of analysis, the level of detail of your failure modes. Now, I'm going to stop and take a look at the comments because I know we've done a lot of stuff here. So hold on one second. Kotesh says, please explain decision tree. Yes, I will do that. Tell something about your professional journey. Okay, Ashish, I will. At the end, I'll do that. Subramanyam, yes. Okay, I know you're responding to my earlier question. Yes, that's right. Measure the vibration and where. Makawe, I don't know if I'm saying your name right. Watching all the way from South Africa. I really enjoy your tutorials. Very eye-opening. Basic things that we should tend to overlook. You are awesome. Thank you so much for that, Magawe. I hope I'm saying your name right. You know, the reason why I'm doing these lives, when I do my lives, I intend to stay basic, but that's because just like anything in life, right? Personal life, professional life, when you don't understand the basics, if I don't have a firm grasp of the basics and a good firm foundation, it doesn't matter how lofty I learn about different things. You got to have good basics. So thank you for that. I really appreciate that. Yep. Tim says PDMA testing may be applicable for all other motor internal stuff. Yes. Yes. And we could get there with that failure mode. Okay. If companies move to IOT applications, they can more specifically focus on predictive maintenance. Okay. So Ashish is talking about IOT, Industrial Internet of Things, and something we're moving into like prescriptive maintenance, which is, it's essentially condition-based maintenance, but instead of a technician going and taking a reading, we would outfit our machines with sophisticated devices. Those send values to a computer system, and then based on preset values, your CMMS or your EAM would spit out a work order. So yes, and that's very advanced, and it's absolutely where we're headed and a way to go. But most of the organizations that I work with, IOT is here. Most organizations are still here, right? So the number one thing is get firm in the foundations and then build, right, on like IOT. And even when we're talking about like industrial Internet of Things, when you do Rcm correctly and you break it down like I've got here, where you break it down into these individual failure modes, then you can identify, hey, for these two failure modes, I could do prescriptive maintenance and take advantage of IOT. But when it comes to like, maybe, for example, something as simple as greasing a bearing, maybe it is just more cost effective, to know that you have to grease it on a specific interval. So not every failure mode is created equal, right? Just like when we get our money, right? When we look at our American dollars, this $100 one is way more valuable than this 10, which is more valuable than this 5, which is more valuable than this 1. So that's why when my mentor, John Mowbray, taught me that we manage physical assets at the failure mode level or the failure cause level, when we do Rcm, we analyze one failure mode at a time. So then we can figure out, okay, what happens if I do nothing to predict or prevent that failure cause? What are the consequences? Then we take it through the decision logic and figure out how we're going to manage it, or if we're going to manage it, because maybe it's no scheduled maintenance, and that's a default strategy. That's a failure management strategy. And if anyone says, "Oh, we don't run anything to failure," I mean, that's just not true, right? There are all kinds of failure modes that we run to failure in any industry, whether it's an airplane or a train or a manufacturing plant or whatever it might be. But if we're consciously running it to failure, then that means that the consequences are not very important. Okay, let me take a look at the chat. Luis says one needs to look at the criticality of the component, brakes, for example, or the impact on safety, production, or finance to decide what or where to apply Rcm processes. Luis, I 100% agree. So at the failure mode level, we assign consequences, right? We do a criticality analysis, but that's what you can do. This is a very simple asset analysis, right? This is a very straightforward one, but you can do a simple one like this, or you can do a formal criticality analysis. But if you're just starting out in Rcm, which we're going to talk about this on Tuesday on our day 3 of this series, if you're just starting out and you want to figure out what should I do Rcm on, I mean, it's like a no-brainer. Do it on your highest cost drivers or the equipment that's giving you the most pain. Just start there. You don't have to have a formal criticality analysis just to pick out a couple of pilot projects. Ashish says, I would love if you can compare theory with real life scenarios. I'm really impressed with your way of explanation. Thank you, Ashish. Okay, I can give you some real world scenarios, and let's do that on Tuesday. So join me on Tuesday, Ashish, and I'll work that in. Yes, Luis, run to failure is also a strategy, 100%. We run a lot of failure modes to failure in our industrial world, absolutely. Okay, so I didn't really plan on this, but let me show you, I think I showed you this. I think I showed you this on Tuesday, but this is a very bare bones Rcm decision diagram. And I'm gonna stop sharing for a second. I'm gonna stop sharing my camera, and so you can see this full screen. Okay. So the way, now I'm not showing my camera, and I would want to show you something about this, but let me just explain it in words. The way to think about an Rcm decision diagram is that it's like a funnel. So you know how when you have to replenish the oil in your car engine and you use a funnel so that you don't spill oil everywhere? Well, you can think of an Rcm decision diagram like that, where once you do your FMEA or your failure modes and effects analysis, well, then you use your Rcm decision diagram and you take each failure mode that you've identified and you put it through this funnel, right? So, oh, am I sharing? I'm not sure if I'm sharing here. I don't think I am. Okay, hold on. See, I'm still new. I got see, I'm not sharing it. All right, so before I start to share, this is what I'm talking about, a funnel, right? This is when you're going to change the oil in your car, you pour the oil in here and you use a funnel so that it doesn't spill everywhere, right? So when we do Rcm, we take each failure mode, remember we talked about that, and we put it through the funnel. And what's going to come out is how we manage that failure mode, all right? So here's our funnel. Now let me share this. Okay, so this is the equivalent of our funnel, our Rcm decision diagram. So we take each failure mode through it. We identify if it's evident or hidden. Hidden is like for protective devices, like smoke detectors or pressure relief valves. We're not going to get that deep today. So let's talk about the evident side, right? So let's say we have an evident failure mode, like our electric motor. Let's say our electric motor bearing wears due to normal use, okay? So we write the failure effect and we identify that now our compressor shuts down and now plant air it completely stops and it adversely affects production. Production stops. So is that going to become evident? Yes, absolutely. We write our failure effect and we don't say anything about safety, but we do say that now production is going to be down for 2 days, let's say. So that has operational consequences. See, now we're going to take this one failure mode through this Rcm decision diagram, and now we're going to consider condition-based maintenance, and we're going to consider preventive maintenance, like scheduled restorations and scheduled replacements. And we're also going to consider default strategies. Maybe is there a training procedure that needs to be augmented, or maybe an operating procedure needs to be beefed up. So you see, think of your Rcm decision diagram as your funnel, and you're just going to analyze one failure mode at a time. And see, that's the significance of when I say that we manage our physical assets at the failure mode level. I'm going to share this back now. I'm going to get super high tech maybe on Tuesday and have 2 screens. So I'll figure out how to do it so I don't have to keep flipping back and forth. But anyway, I think we're doing okay together. Okay, so there you have it. So that's your Rcm decision diagram. And this is Rcm in a nutshell, right? So you do your FMEA, and then that's the first 4 steps. And then you take each failure mode and you put it through your funnel. And you assess criticality here. This is step 5. And then this is step 6 and 7. See, that's it. And when you write your failure modes properly and at the right level, and you don't get yourself into analysis paralysis, it's a very common sense approach. But a lot of people have the wrong idea about reliability centered maintenance, or they've only seen it done one way, like the wrong way, and they didn't get the results they wanted. And it took them 3 months, to do an analysis on a motor, which is, in most cases is not the case. Okay, now I'm just going to have a look at the comments. You're welcome, Ashish. Okay, Subramanyam, when is run to failure strategy cost effective? Run to failure is cost effective. Now, we're assuming that we don't have safety or environmental consequences. So we're assuming operational or non-operational consequences. Run to failure is cost effective if letting something run to failure is cheaper than doing the maintenance, right? So remember on Tuesday, we talked about my 2014 Subaru Forester. Is it cheaper for me to spend $100 a year changing my oil twice a year, or never changing the oil and running it to failure? Over 5 years, I'm going to spend $500 having my oil changed, right? But if I don't change my oil, over 5 years, I'm going to end up with some serious engine damage, maybe $5,000+ worth of damage. So you see how it's definitely worth it. It's cost effective. And that's what this is a very bare bones Rcm decision diagram, but see within each of these boxes, that's the kind of analysis that you do. Yes, Luis, analysis paralysis. Yep. Okay, so let me see. I'm going to stop sharing for a second. Let me go back here. I thought I was sharing me partially. Oh, that's why. Okay. I'm going to go back to sharing now. Okay, so I think it was Ashish who asked about let me look. I'm looking at the comments real quickly. Yes, Ashish wanted to know about my professional journey. Okay, so I'll tell you super quickly. When I went to school. Oh, no, that's not what I wanted to show. Here we go. So I went to college in Daytona Beach, Florida at Embry-Riddle Aeronautical University. So my degree is in aerospace engineering. And when I was a senior, the U.S. Navy came and recruited at my school for the position of a logistics intern. Well, I applied and I got the job. And so I started working right out of college, and I moved around a lot, but I ended up at the Naval Air Warfare Center in Lakehurst, New Jersey. And if you've ever been an intern, put in the chat if you've ever been an intern, because a lot of times interns, you don't always get the most exciting work, and you don't get a lot of work to do sometimes. And I like to be busy, and I like to be using my brain. I'm not one to just be idle. I very much need to be productive. So I was really bored. And then one day my supervisor called me into his office, and he said, Nancy, we've been tasked from above. And I remember he did this with his hands. He said, we've been tasked from above to do reliability-centered maintenance on our equipment because we need to reduce maintenance costs. And he looked at me, and I'm writing this down, right? I got my notebook, and I write down reliability-centered, what did he say? I think he said maintenance. So I write down reliability-centered maintenance. He said, I need you to go figure out what that is and what we have to do to implement it. Now, how was I to know that 10-minute meeting on an otherwise ordinary day in August 1997 would quite literally set the trajectory for the rest of my life? Because we did do reliability-centered maintenance on support equipment, and we started with just a few small pilot projects. And that's what I'm gonna show you tomorrow, the logistics of starting to do Rcm, right? I don't want you to think about it like starting an Rcm program. I want you to think about it as just trying it out. And that's what we did within the Navy. And based on the strength of the pilot projects, we instituted a full-blown Rcm program. And I'm really proud to say that 23 years later, that Rcm program is still going strong. Now, I left the Navy in 2001 because I wanted to apply Rcm more broadly to different kinds of equipment. So I started my own business, and in the last 23 years, I've facilitated Rcm analyses on all kinds of equipment, notably our Army's heavy lift helicopter, the Chinook, the CH-47 Chinook helicopter. I did a lot of work with what was the Y-12 plant in Oak Ridge, Tennessee, where they refurbished nuclear weapons. So I've done Rcm on a lot of different equipment. And what that experience has taught me is, so two things. Number one, when you do Rcm correctly with the right people, it can transform an organization. And I'll show you some results tomorrow, because I think it was Ashish who asked that. I'll show you that tomorrow, but it can quite literally transform an organization. Is it overnight? No. Does it take 10 years? No, but it doesn't happen overnight either. It's like anything, right? You have to keep doing it. And there's a technical component to it, but there's also a people component to it, right? We hear a lot about reliability culture. And one of the ways you build that reliability culture is by educating people about what reliability even is, and then to include them in your Rcm analysis. That's absolutely key. We'll talk more about that tomorrow. So that was my professional journey. And then one of my hobbies is I love to play No Limit Texas Hold'em tournament poker. And so I haven't played poker, of course, because of world circumstances in so long, and I really miss it. But one of the ways I learned how to play is by taking some online courses. And so one day I walk in back to my office from Pilates, and I thought to myself, if I can learn poker online, then why can't people learn reliability-centered maintenance online? Now, Rcm is over 50, Rcm principles are over 50 years old, right? But still, a lot of people don't understand the process, and it's still applied incorrectly a lot of times. So my mission is to be able to teach more and share more about Rcm in an easier way. So instead of having to have, for example, a consultant come and teach, if you want, you can take online Rcm classes. And if you haven't already taken it, you can go see that URL, rcmtrainingonline.com. You can go there, and I've got a free Rcm course. If you haven't already taken it, you can take that. And then, of course, I have more advanced courses if you're interested in that. But that was my journey. And so I feel very passionate about Rcm. And someone might ask, well, as technology advances, do we still need this common sense process? And I would say, absolutely. I think that Rcm is more relevant now than it was even 20 years ago, because a lot of times, I think a lot of times organizations will kind of gravitate to technology as solutions, and technology can be a solution, but it still needs to be implemented appropriately, and people still need to implement it. So again, we get back to the basics, where we absolutely need to have a firm grasp of the basics. Okay, I'm going to look at the chat real quickly. Luis, does one maintain a fridge or run it to failure? I can speak from personal experience about this, Luis. I run my refrigerator to failure, except for one failure mode, right? And I just bought a new refrigerator maybe a year ago. And for a while, it was making this noise like, like zzz. It was obviously something was going bad. And I would just kind of bang the refrigerator and it would go away. And I said to myself, okay, I think I might I think I'm going to get pretty close to running this to failure. But so I didn't actually, I guess I kind of condition monitored it, because it still made the noise, but then it wasn't really, I guess I did run it to failure because it wasn't cooling properly. My things were starting to freeze, and then it wasn't getting cold enough, and I had to throw food away. So I eventually bought a new refrigerator. So I essentially ran it to failure, except I have a water dispenser as part of my refrigerator, and there's a filter there. So I changed that filter, when the little strip indicates that it's ready to be changed. So I run my refrigerator to failure, except for one failure mode. And you see, if we go back to our electric motor, remember when we talked about, when we showed this, right, with this electric motor with these failure modes, this one was our black box, right? Fails internally. Well, essentially what I do is water filter, it doesn't really clog. It loses its ability to filter due to normal use, due to age. And then my other failure mode would be refrigerator fails. And I would run it to failure. Ashish says he knows internships. Ashish says, I would love to do a joint training or webinar with you. Okay, Ashish, send me a message and we can talk about that. Thank you, Ashish, for my journey through 2 decades. Okay, Subramanyam wants to know, is Rcm applicable equally for both greenfield plant as well as brownfield plant? I'm not exactly sure what you mean about that, Subramanyam, but I can tell you this. You can do reliability-centered maintenance on anything. On any piece of equipment, in John Mowbray used to say, in any area of endeavor on the planet. I've done an Rcm analysis on a tech manual before, because the tech manual was so bad. It was really bad. So we actually did Rcm on it. We wrote functions. We went through the whole step. Now, obviously, step 6, all of the answers to those questions were no, because there's no proactive maintenance to do, but we came out with a lot of default strategies. But the key to the first step, let me go there. The key to the first step in the Rcm process is when we write functions. And remember, yesterday we talked about when you write functions, you're essentially defining the kind of reliability that you need from your equipment. So when we did this analysis on the tech manual, we identified exactly what we needed from the tech manual, specifically what we wanted. So we were able to identify the deficiencies, and then we documented what needed to be changed. Now, the key to this is you might step back and say, okay, yeah, but hold on. Do we really need an analysis? Can't we just sit down and write what we need to fix it? Well, number one, we had the right people around the table doing a formal analysis, but the key is we had a formal analysis. And when you do Rcm, you have a complete audit trail of all your failure modes, which is essentially this. Hey, if you don't do this task, this is what's going to happen. So it elevates issues to management in a way where you don't have to actually show them your Rcm analysis, but you can summarize the results in a way that says, hey, if you don't make this design change and this failure occurs, you're going to be down for 2 weeks, right? So you can talk to them in their language, the language of money, right? With the way that they're thinking, because we all think differently, right? A reliability engineer is looking at reliability. Operators are looking at one thing, maintainers, production, CEOs, middle managers, right? Everyone has a goal. Everyone has their own job, their own responsibility to fulfill, right? At the end of the day, everybody wants the same thing, but not everyone is thinking the same way. And that's one of the ways that you pull people in, is to talk to them in their own language. But that's a whole other topic. Okay, let's see. Oh, Subramanyam, both new and old equipment. Absolutely. And I agree with you. Sooner the better. Because how often do we procure a new piece of equipment and we put it into service and it doesn't do what we need? Or the hookup is on this side and we don't have enough hose length to get to it. I mean, there's all kinds of things. So yes, sooner rather than later, but when we started to do the analyses on the Chinook, that airframe was 40 years old, and we started RCM. The support equipment, when I was a Navy employee, when we did RCM on aviation ground support equipment, some of that equipment was 10, 20, 30 years old. So if it's going to be left in service for several more years, then absolutely it could benefit. It doesn't matter how old it is. Okay, Tim wants to know in what phase of an upcoming project should an RCM be performed for new equipment being installed? Tim, I say as soon as possible. If you can do it in the design stage, we hear a lot about reliability-centered design, but when you think about it, it's essentially, I use the word essentially because there are some differences, but it's essentially RCM, because when you start with functions, you don't write, when you write functions, when you do write what the equipment was designed to do. You write what you need the equipment to do. And that's what allows you to figure out if the design is capable of doing that or not. So even when it's just an idea on paper, you can start this process and then just keep refining it. Now, your failure modes, obviously, when it's still in the design stage, your failure modes are going to be different than when it's final, but you'll have several iterations of the process. Okay, so let's see. All right, so that's what I have for you for today. Now what I want to do is let me give you a quick preview to tomorrow, and I'll pause so you can put any questions that you might have in the chat. Here's what we have online for tomorrow. Not tomorrow, I'm sorry. For day 3, Tuesday, at September 22nd at 11:30 Central. And I'm actually thinking of maybe doing that even earlier. Hold on one second. Let me check something. Okay, yeah. I'm going to change this to 10:45. So here, let me change it here so you have the... Okay. On day 3, we're going to talk about the logistics of pilot projects. Essentially, what I mean is, how do you start? And I don't want you to think about it as, how do you start an Rcm program? Because that's not what I'm talking about. I want you to put in your head, if you're thinking about doing Rcm, I want you to put in your head that you would start out small. You'd start with a couple of pilot projects. Don't think you have to do a full-blown Rcm program. It's very important that you and everyone within your organization understands what Rcm is, what it takes to do an analysis, and that you get the results that you need and want from it, right? So on Tuesday, September 22nd, I'm going to take you through how you would do that. How would you start by doing a couple of pilot projects? All right, so that's what's up. That's what's up for day 3. I'm going to look at the chat one more time to see if there are any other questions, and then we'll end this session. But let me just mention one more time. If you're not on my email list, then please go to rcmtrainingonline.com/subscribe. And then that way you'll get email alerts to when I'm going to do a live on LinkedIn. Sometimes I do live webinars like on Zoom. I post weekly videos about reliability. So anyway, if you're not already subscribed, then please do so. And I'm going to look at the chat one more time. Thank you, Kotesh. Okay, I'm just making sure we don't have any more questions. Okay, so I think that does it. There aren't any more questions. So I will see you, hopefully. I hope you will join me back here again for day 3. We're going to talk about the logistics of reliability-centered maintenance pilot projects. Thank you so much for your attention today. It was a sincere pleasure, and I will see you next week on Tuesday. Have a wonderful and safe weekend, everyone. Bye-bye.